So here we go. Let S be a set of complex numbers. A function f defined on S is a rule that assigns to each z into S a complex number, say this. So I'm going to, as I did last semester, I would be basically, we'll be going through this situation where I'll be typing. So I'll be sharing my screen with you. I don't know, you have the slides. The slides are uploaded. So I think I'm just going to share my LaTeX where I'm going to be typing because I'll have to type through the class.
You fool.
So let us start with this. Consider z is equal to 2 plus 3i.
This typing in the phone.
For electricals, please get rid of that feedback. Please. I'm having a very clear feedback. Thank you. Electricals, most of your textbooks will reserve the I. Will reserve this I for what? Current. Electricals, you don't use I, you use J for the imaginary part, complex number. If Z is equal to 2 plus 3I, then Z squared is equal to what? Two plus 3I all squared. If it's on condition. This can be given as what? This can be expressed as 2 squared minus 9 squared. So you have negative 5 plus 6i. Is this true? I am just testing your complex numbers, basically. If we agree that this is true and we don't have any problem, then we can move on. Is this true? So Mauli took you through one, you have done complex numbers. So I want to know if z is equal to this, z squared is this. Is this true? Can we have minus 5, 6i? If we agree on it, then I can move on.
Hello. Yeah. I'm the guy you came to. I'm the guy you came to give the this thing to the cooker to. Original one.
I'm waiting for a response, please. Sharing my screen with you guys.
Yes, sir. Yes, sir. Yes, sir.
Which screen am I sharing?
If this is equal to 2 plus 3i. Please, I cannot hear anything.
Yes, so if I'm sharing something with you and I'm asking you a question, I'm not sure why you wouldn't even communicate.
get a minus 5.
This is correct.
I mean, you say you go do the class. How you money no say?
I get minus 5.
I'll be there. This already.
2 squared.
No. Complex numbers. You see the I squared will give you minus.
So there's 6, there's 3 I squared. No, will give you minus 6.
I still will give you minus.
Yeah, like
Yes,
complex
I
numbers.
squared will give you minus. So
Where you?
3 I squared. You know will give you.
So man, I don't get them for you.
No, I don't.
I do.
See the 2.
Yeah.
But no, from 2 minus 3. So I get a 5.
I get 5 for you. I do the bar.
I think I was such a little now.
Hey!
Hey, tell me.
Hey, for me step there.
Tell me. How did you get the 5? Boy,
See what?
you think that's where you trying to get.
Hey! This maths. I think I saw it, you see.
Okay.
Keys.
So it clearly tells me if z square is this, then I can then we can call z a variable,
How be 5?
4 minus
call
5.
z
Give you minus 5.
a variable,
Give you out.
Where? That's 6 comes from.
There are today, man.
call z a variable,
The plus 6 I.
and f of z equal to z squared, a function.
6I plus 6I. Now it will be 12I7 plus 12I.
No. It's 6.
So I gave z is a number and I wrote this, but I can always have this. F of z is equal to z squared. It's a
Yeah.
function.
Yeah,
Yes.
when you do this thing, you get negative 5 plus 12i. Yeah,
For
exactly.
12i. Thank you. I think I agree with you. 4 times 3, 12i. Thank you. The confirmation I needed. Thank you. I'm glad you went through
Yes.
it to get me the answer. Thank you. Good. From this, it means that I can call z a variable, and then f of z is this. So we have a function of complex variables in the form f of z whenever the variable z is a complex number or takes some complex number, belongs to the complex plane, is in the complex plane. If there's something I have written that you don't understand, please feel free and ask questions. And as I have said, please, online lectures, it's as if you're seated in front of me in the lab complex and we are having lectures. So please sit down, take notes. I'm not sure where you are, but if you can create a space, even if you're using your phone, you can sit down upright, have your phone and write notes. It will help. We've gone through this for some time now. We've gone through it at one point last semester. We still have to go through this. The whole of last semester was online. And so this is like another semester that we are doing this. So we've gone through this cycle for 1 year because COVID came in 2020, what's it called, March. So if you're in February now, we're almost doing a year, one academic year now, and nobody knows if we are ever going to have um, in-person lectures or not. But still, people need to be educated
Hey, this is a trick.
because we still have problems that needs to be solved.
A money loss.
And the only way to solve it is first of all we must acquire knowledge. So we have any function. When we talk about functions of complex variables, it means that we are dealing with the function f of z, and z must be a complex number, or z can only take complex numbers. That is what that information on slide number 5 is talking about. I clearly said that let S be a set of complex numbers, and then we define a function which takes on numbers from the complex plane Z, complex plane. Can you, if you don't have anything saying to me, don't just mute yourself and stop disturbing the class, please. So we have a situation where you have to find a function, and then every variable of that function will be coming from the complex plane. What it means is that if you take this function, you can have another function which belongs to the complex plane. Let's look at an example. So, as an example,
Then you what?
You go disconnect you. You go disconnect you.
If the network is slow, you don't go see. You don't go see.
we let z to be equal to this. We let
Then you
z
what?
to be equal to this time x plus iy. And f of z is equal to z squared. If we do this,
Tell me, you can disconnect from there. You'll not fit at data.
what do we have? What will be f of z? F of z will become this, equal to x plus iy all squared. This is the same as what? S squared minus y squared plus 2xyi. Check and confirm this to me. If we let z to be this, or let's say just let, I can just use the word let. Let me create a space. Three space 5 minutes, and then I just so I can just you see if z is equal to x plus iy and f of z is this, have this situation where f of z is equal to x plus iy all squared, just as we did this. I'm just using the same example, but instead of fixing 2 and 3, I am defining z as a variable. In this case, z is a complex number. Here, I just have one number. It's just one complex number. Please, what is the difference between a number and a variable?
A number and a variable.
And with students who can tell you they have forgotten. So, what is the difference between a number and a variable? I'm waiting for an answer.
Specs. Answer the question.
I mean, variable you get letter by
Answer.
That's the answer.
If you think for your
I ask the teacher me.
Yeah, variable numbers be.
They don't get letters by
What is the difference between a number and a variable?
Variables are not defined.
A variable is attached to a number.
I don't know what you mean by variables are not defined. What is your meaning? What is your definition of defined?
Please, a variable is like could be a letter or something used to represent something in
That is the most confused definition of a variable I've ever heard.
These are the most confused.
Second year engineering students, what is the difference between a number and a variable?
Second year engineering student have to go to
See the plenty talk that boy can't talk, so they can't clean the water.
A number can be constant, but a variable can vary.
Therefore, therefore,
They said all cap to get
so in a way, a number is just a constant. 2 is a number, and it's just 2. It will never change. It won't go anywhere. 2 is 2. 2 plus 3i is just one complex number out of the millions of complex numbers in the world. A variable can take on any number. Variable takes on numbers. A number is just one unit out of the millions of numbers in the world. You can call it a constant, that's fine. But variable keeps changing. It's variable, it keeps changing. It can take on any other number. Good. So in this example, the very first thing I did was I used the complex number z is equal to 2 plus 3i. And then I expanded this complex number to see what I'll get. Now I'm calling the method, what I used to get the new complex number. If you look at this, 2 plus 3i minus 5 plus 12i. What is the relationship between them? I have to square the first number to get the second number. I'm saying that, okay, let me call z a variable, which means z can take on anything. And then I'll define a function f of z is equal to z squared. For me to be able to get a general expression for the function, I am using a general expression for the variable z. Z is equal to x plus iy. In this example, x is 2, y is 3. But now I have x and y, and they can take on anything else in the world. Any number, x can be negative 2, y can be negative 5. They can be anything. But now I have turned them into a variable. And then I have defined a function. I now have a relationship between x plus iy, and then the function, I can get x squared minus y squared plus 2xy. This clearly can be written as what? Therefore, we have a complex function with the expressions f of z is equal to u of x comma y plus I v of x comma y. And I'm sure you know what I mean by this x comma y and so on. You have dealt with functions of several variables, right? You've dealt with the function f of x comma y. Based on this, when u of x comma y is equal to what? X squared minus y squared. And v of x comma y is equal to 2xy. Let me clear this, clear page. Good. Look at this. So if you find if z is a complex variable and f is a function of complex variable, then we are expected to get another complex expression. That is the real part and the imaginary part of that function. And the example we have, which I'm using to explain this, clearly shows that the real part, which is the u of x comma y, is x squared minus y squared. And then the imaginary part, that is the I part, is 2xy. If you look at this, you have a function of one variable z generating into a function of two variables x comma y. One of the things you should get from here is that functions of complex variables are more or less a transformation. Look at this. If we go back to our example, e is 2 plus 3i. It's just a complex number that you can actually plot in the complex plane. Plot this in a complex plane. I'm going to share it on what's it called? I'm going to take the use Inkscape to sketch this, which ideally I would have done. Let me see if I can use the Jamboard to sketch. Use Inkscape to sketch. You can indicate in the complex plane 2 plus 3i. You can also indicate in the complex plane minus 5 plus 12i. Use Inkscape to do the sketching. All right, so I'm going to share my Inkscape screen with you now. Okay. So I have this, I copy and I paste, and then I just rotate. 90 degrees. So yeah, I have my x-axis and so on and so forth. Good. So this is the positive side, this is the negative side. And now I am looking for what? First of all, do my test. I need 2 plus 3i. So I'm going to put by extension latex, I have 2, 2, which I have to indicate. So complex numbers are mainly, they form a plane because of the real part and the imaginary part. Then I have 3, 2 plus 3i. So I have the real part of z and the imaginary part of z. I have real part of z, imaginary part of z.
Which are you just 2 plus 3i? Or
Come
3
again.
plus 3 high?
Come again. So what are you saying?
Sir, did you just say? Hello, can you hear me, sir?
I hear you.
Okay, you just you stated, is it 3 plus 3i or 2 plus 3 high? Because what is on the board is,
Plus 3,
I don't know,
plus 3i.
3 plus 3 high.
This is
What the one writes for
It's
them?
overlapping. Your numbers are overlapping.
I'm not sure. So this is the imaginary part.
You know, answer the question.
This is the real part. I want to sketch it somewhere here. And the 3, that is the imaginary part. On the imaginary axis, I'll go for 3, and then the real axis, I'll go for 2. Then I can sketch it should some here. I'll go for this. And then I'll increase that to say maybe 5. I can change the color. Say blue. Yeah. I realize I need to do something because of the other one. The other one is 12, right? So let me bring this whole thing down. Good. So I have this. So I can move my 2 right here. This is 2 and this is 3. This is the complex number, and it's more or less, complex numbers, you can find the modulus, the length, and then the argand, the angle it makes with what's it called, the real axis. So this is the imaginary part, this is the real part, this is the complex number that we have. But if we take z squared, if we take the translation of z squared, what we are getting is negative 5 and 12. So this gives me hope I'm sharing my Inkscape, right? You can see my sketch.
Yes, sir. Yes, sir. You can see.
So you just need to do that.
Okay, so I have this negative 12. Let me put the negative 5 somewhere here, and then let me just put my 12 somewhere here. Let's assume that it's 12. That's weird. Anyway, if this is 3, this can be 12. It's not drawn to scale, so don't worry about it.
Sometimes you will talk something,
Copy this
you know the thing will come appear.
and paste it somewhere else. I'll change the color.
You will talk, you will, like the thing will be effective, maybe.
Red. Do this. It's gonna be somewhere here, basically. That's where it goes. I can just change my I'll change it to 5. Change it to 5. Good. And this now is what? Negative 5 plus 12i, which is z squared. So I think I need to edit
You get back for
those
you.
ones.
You get back for you.
I need to do something else. Z is equal to 2 plus 3i. Then uh, z squared is equal to negative 5, negative 5 12i.
I did think. I did look the money from me.
Let me see how it pops up. Okay, so I'm gonna do something. Close this. Open another one.
So I'm actually having second thoughts. So I'm still not having second thoughts. I'm not now. Yeah.
Good.
To have this lecture face to face. And then, yeah, there are actually a few
So this is right here. I can delete this now. And this is
they
right
are
here.
conversing on the platform. What's up?
Okay, so I'm going to ask you a very simple question. I went through all this so I can ask you a question. My question is this. What do you think is the relationship between z and z squared? Delete.
It's a reflection.
What do you think is the relationship between z and z squared? What are some of the similarities, differences? What can you say about it?
So if it was a deflection, they will actually have the same magnitude. They have different magnitude.
I'm waiting for an
What I know
answer.
is
If you
that
can see my
what
screen.
is similar to them is that they actually fall on the same positive. Oh, okay, no, they fall on the same
They originate from.
plane.
They all come
Is
from
someone here with me?
Yeah, yes, sir.
Please speak out. What's the relationship between z and z squared?
Z is small, Z square is big.
everything, you know.
Enter with 7 legs.
What can you see? What can you see between the blue line and the red line? Basically that.
The red line is longer than the blue line.
So it means that the magnitude is larger, the magnitude of z squared is larger than the magnitude of z. And then,
We said
what else?
similar. We said similar.
Yeah.
We said something similar. How is it making a difference now?
The real number is positive and the real number of the z squared is negative.
Therefore,
Therefore, z is positive. The value of z is positive and the
I
value of z squared.
don't even, that is just a confused person speaking right now. Those signs tell you something more than one is negative, one is positive. The signs tell you something. They tell you about their location. One is in the first quadrant, one is in the, what's it called? The second quadrant. So it tells you that basically you can look at this. This can be what, like a translation or a reflection. So this whole process, the line, the difference I want to express here is that, or I want to be able to point this out in today's lecture, that complex numbers are very different from what real, complex functions are very different from real valued functions. In real valued function, if I give you the values of x, you have to just find the values of f of x, and you then you get one graph. However, in complex value functions, complex number z, it's a sketch or it's a graph in a plane. And when you carry out the operation using the function, you have another graph altogether, which is either going to be a rotation, a reflection, or a translation. What's it called? The initial object. So this is like an object and this is an image. So when you go to the tenth,
How could it be how could it be a reflection when magnitudes are different?
I can't hear you, please. I know someone is speaking, but I can't hear.
Yeah, sir. How could it be its reflection? How could z squared be the reflection of z when the magnitudes are different?
But you can have things happening. It is reflected and then enlarged. Is that not possible? When you take a mirror, do you see your own height in the mirror, or you can see a smaller height, but that is your reflection?
You get it. It's reflected in.
So I don't get you, sir.
Are you a physics student?
Yes, sir. Yes, sir, of course.
Ever studied physics? Good. So if you have a particular mirror, project an object into it, you expect to get the same object height and object distance and other things in the image, or they can vary depending on the mirror you're using.
Oh, yeah, they vary.
Which can be smaller than the object. Which can be smaller than the object, right?
Yeah, exactly, sir.
Can be the image can be larger than the object, or the image can be smaller than the object.
Yes.
So can be two different operations going on. It is a translation or a reflection and an enlargement. It happens simultaneously.
Just like when you're using a concave mirror, and then
What I want to point,
one gives you an enlarged image and one gives you a diminished. You understand what I'm saying? So it's still a reflection. You get it.
Yeah, look at.
that is,
What for menu?
Something is wrong with this motor.
That's fine. That's fine.
they're just fun you work with. In complex value functions, they are basically formation, because they transform the complex number a new
Why?
it, it most critical thing that I need to get off meeting out from today's lecture. Join relevant content in the comment. That's why
Okay.
I'm going through the trouble sketch this, which you're gonna ask me to do this for you, which I will
I think it's ideal actually have this nice
as well. Any other question?
Why do we have differentiation before integration?
What do you say?
Wait. He's not talking now.
Speaking. Okay, so can I go back to my slides now? I've actually just said what I needed to do.
He left the slide.
Are you using this?
Yeah.
Can I go back to my slides now?
Yeah, so sir, please, with the graph you just drawn,
Yes, yes.
what are you trying to prove?
No. Or use your this one. No. This my man. He might know they give attendance. I just left my phone.
Hello.
Sir, you know they see the screen. No? Thank God.
Hello, sir.
Tell him that you can't see the screen. The slide.
He's showing the screen.
Hmm?
He's showing the screen.
He's sharing it right
It's
now.
blank. It's not coming up here. Yes, sir. So all I was asking is that from the graph you just drawn, what are we trying to prove out of the graph?
Your feet are not even coming here.
Hello, so can you hear me?
Okay, I lost connection.
Huh?
I lost connection. The class will go to this.
Sir? Yeah, can you hear me, sir? Hello, sir, can you hear me? So what I was saying was that from the graph you just drawn, what are we trying to prove out of the graph?
Yeah. You get the meat up. No. I use the web one.
It looks like the timing is different. Sound is slow.
Your one is down.
The timing is different. I've spoken for a very long time now, and he's just listening to it. Or he's just responding. So can you hear me now?
I'm not use my data answer. If I now go use.
So what is all he has got so far?